Hi everyone, this is Diogo Mendes from Arista Tech team, and in this video I will show you how to set up a very quick and powerful lab environment using Arista cEOS and Containerlab. I will start by explaining why this particular combination is currently my favorite go-to option for quick and even large-scale virtual lab environments. I'll go over the overall steps regarding how to set it up, demonstrating how to do it in a Linux machine, or in my case, a Linux virtual machine using my MacBook as the host. And by the end, I will show you how easy and convenient it is to create your own topologies, modify existing ones, deploy labs, access your cEOS instances, deploy some base configuration, generate graphical topology diagrams, and also how to stop the environment after using it. One of the key points that makes this approach my preferred one at the moment is that instead of relying on deploying virtual machines as usual, we are using containerized version of the operating system. And in comparison, this is much more lightweight, quicker to run, and also allow a more streamlined workflow, as you will see. Arista offers a containerized version of our operating system that is free for download on our website and to be used for lab testing environments, which is called cEOS-Lab. It's a great tool that can be used by anyone with different use cases, such as testing and validating configurations, designs before deploying them in production, make it easy to test automation, script tools, locally deploying environments way quicker than having physical gear, and provides a convenient way to test and learn EOS and its features by anyone who might be interested in it, like students, professors, network professionals, etc. Since it's the same EOS but in a containerized version, it has pretty much the same features apart from the ones that obviously require specific underlying hardware for it. Another very important part of our solution is Containerlab. This is an open source tool for orchestrating and managing networking labs using containers. It provides a simple and scalable way to run lab topologies very quickly by using YAML files to define all the necessary parameters. Once you get used to it, it's quite simple in comparison to other options, and it's also very efficient since it uses containers instead of VMs. It offers an infrastructure as code type of environment, which means that all the lab configuration files can be managed and shared as code using repositories such as GitHub and GitLab. And last but not least, it's a vendor agnostic solution that can support different kinds of devices, from network operating systems of different vendors to Linux hosts and applications. So in order to prepare the environment, we need to make sure that our environment meets some requirements. First of all, since Containerlab is a Linux application, we need to have a Linux host, which could be your own computer, a server, a virtual machine, etc. Then we need to make sure that Docker is installed to create and manage the containers. You can install it manually, but this can also be done automatically by the full installation script that is provided by Containerlab developers. And finally, we need to have the container image file from our system, the systems that we want to run. In your case, in case of EOS, you can download the cEOS-Lab image directly from Arista's website by using a free account. There are also some requirements that may vary according to your particular deployment. For example, in my case, I will run Linux as a virtual machine using OrbStack on macOS. The virtual machine will be Debian, although you can choose others if you like. Then, to interact with this environment from my MacBook, I'll be using Visual Studio Code, VS Code, with a remote SSH extension installed. You're free to use your preferred methods, even just a regular terminal can do the job, but you see that this combination can give you very cool tools to improve your workflow. As previously mentioned, you need to download the cEOS image from our website, and this can be done on the download page after logging in with your free account. You'll notice there are multiple images available, and the most important point is to make sure that you download the right one based on your computer architecture. So for example, typically PCs and servers will have x86 chips, so you can download the regular, let's say, EOS-Lab image, but you also have computers like Apple, Apple M1, 2, 3, 4, etc., that have the special Apple Silicon, and also Raspberry Pis or any other computer that is based on ARM architecture. For these ones, you need to make sure you download the version with ARM in the name. Now let's go through the steps necessary to set up the environment and also run the labs. I will start by going to the Arista software download page. As you can see here, I'm logged in with a user that is not a Arista partner or Arista user, customer, etc. So here you can see that I do have access to cEOS-Lab and VOS-Lab. I'll go through cEOS-Lab and you have multiple different versions here available. I'll go for the newest one. So it's a EFT or field trial version. And as you can see here, we do have a version that is x86 ready. So it's for x86 platform, while we also have this one that can be used for ARM processors, right? And in our case here, I'm running my setup in macOS. So, and this macOS is using Apple Silicon M4, so I'll need to download this ARM version. So the image is now being downloaded. Now we can run our virtual machine in using different methods. I will particularly use this OrbStack option as it's quite convenient. It's very easy, very quick to deploy a virtual machine and set things up. I'll show you step by step how you do it. So essentially you just need to click on new machine or the plus sign here. Then you choose what is the flavor of Linux you're gonna deploy. In our case here, let's go with Debian. You can choose the one that you are more used to. I guess just to make sure that you have no issues, probably you should have a look in. We probably should consider one that is very well known. So Debian, Ubuntu, or Fedora, CentOS, Alma, whatever you like. I'll go with Debian here. Then you have the choice of CPU type. So this is the system architecture. You can choose Apple Silicon or Intel. Our case here we have Apple Silicon, and we can just hit create, and it will take like few seconds, and then after that the machine is already properly set up. If you double click, you're gonna be prompted here to accept. It's a warning message. I'm gonna open your terminal, and as you can see here, I have a terminal open, and if I check, for example, etc issue, I do see I have a Debian GNU Linux 12. And if I open another session, like a completely separate session, this is the terminal on my MacBook, right? This is the actual MacBook terminal, and this is the virtual machine terminal. So it's pretty cool that this application, OrbStack, it allows us to have this level of integration where you can just directly open your terminal in your virtual machine as you were in a local machine. So at this point, since I'm already in the terminal, what I'm going to do next is I'll run the script to install Containerlab. So this option here will give us automated experience. So everything will be built automatically. All the requirements will be installed. So you can just copy this line and you can run on our virtual machine terminal. You can just wait for a few seconds while all the steps are being performed, all the packages are being installed. So it looks like the script has finished. There are some errors here by the end, but this is something I noticed in previous installations, so there should be no issue. The easiest way you can now confirm whether or not this setup is properly installed. If you run Containerlab version, you can see the latest version has been installed. You can also use cLab version instead of Containerlab version, just a simpler shortcut here, so you can more quickly run the commands. So we could start using Containerlab right now using this terminal here. Although I like to use VS Code instead, which give us like a better optimized workflow in general. So you have everything in one place, the terminal, and also you can explore the file system through the file explorer. You can also integrate to GitHub, Gits and GitHub very easily. So I'll now go to VS Code in order to finish the steps. So this is the VS Code interface. VS Code, if you're not used to it, it's a great tool. It can be used for different things. If you're a developer or work with automation, probably you already know VS Code. It can be used as a full development environment, but it can also be used just to, read files, text editor, etc. It's quite handy, and there are a lot of good things about it. For our case here, the main use case will be to connect to the Linux machine directly from our macOS host, and having the ability of opening the file system through this file explorer, along with also the terminal being available on the remote machine in the same window, in the same application. There are many more things that you can do with VS Code. In future demonstrations, we're going to be exploring some of the additional features. But for now, what you're going to need to do is you need to install an extension, and the extension is another thing that makes VS Code so great. You have multiple different extensions to expand the functionality of the application. The one we're going to be using today is this remote SSH. So in my case, I already have this installed. You can just search for it here in the extension marketplace and install it. And once you do that, now we're going to be able to use this application. In order to use it, you have different options. One of them is to click on this blue icon in the left hand side, the bottom of the screen. You can see a menu open with this option, connect to host. Another option would be to click in view and command palette. It's the same, you're gonna have the same option available. And the last one is the shortcut, which in macOS is Shift Command P. So it will also open this window. So you can just choose connect to hosts from this, or from this one, and it will prompt you for the username and host. In your case, due to the integration between macOS and OrbStack, we already have a name associated with your virtual machine, and if you type orb, it's gonna automatically SSH into your remote virtual machine here. Another window is opened automatically by VS Code, so you can just make it a little bit bigger so it's easier to visualize. And here you can see we already have our terminal logged in into our virtual machine. And if you do etc issue again, we see it's our Debian machine. We can also see that my working directory is in the file system of this VM, which is fine. You can work from there if you want to. But the other very cool thing that this type of setup provides is the ability to share the file system between your Linux VM and your local computer. So you see what you're going to do in this case. We're going to leverage this feature, and we're going to work with directories in your own MacBook laptop. The way you're going to accomplish that is simple. One of the easiest options here is to click on Open Folder, and by default it looks into the file system here of my virtual machine. However, I can easily just type here the path in my own computer. So I can go to my directory here. I'll use this demo directory, and there is nothing currently there. So you see demo in SSH orb is now connected. If we open again our terminal, that's where we are. So if you want, we can just create some files here. You see that they appear automatically. But you could just, like, if you want, you could just start creating your own topology files and deploying that using Containerlab. But one of the easiest ways to do it is by downloading or cloning some of the existing repositories with already some examples of labs. So that's what we're going to do as well. So here we have our repository with few files that can be useful for us. So if you go here in code and you copy this address and then you go back to VS Code, you can do git clone and the address, and you see that clone the repository has been cloned, and now I have this directory. If I enter this, I have all my files from the repository there. And the one that we are interested at the moment, it's called Topology YAML. If you use code and the name of the file, it opens the file directly here. So again, very good to have this integration between the terminal and the text editor. So here we have extremely simple topology called sample. I removed the prefix. That's an option parameter that you can customize. It's just that to simplify the name of the host names, as you'll see in a few minutes. And here we have the definitions. So my topology, I defined kind as just one kind. We have COS. I will be running this image, and both of my nodes here, both of the containers that will be created, they have the same kind. So they are gonna get their information on how to build this container based on that. Again, there are several parameters and a wide variety of things that can be customized here, but let's start from a very simple lab, and then we'll build on top of it in the next sessions. So at this point, what I'm missing here is the actual image. If you do Docker images, for example, here I see that I have Docker installed, but I have no images available. In your case, we already downloaded the cEOS-Lab image from the Arista website. So the next step here will be to import this image to Docker. The way it's done is quite simple. You could just drag and drop the file here if you want to, but if we know where the file is, I have access to all my files in my local machine. What I can do, for example, is just do docker import, and then I search for my specific file that is called COS ARM Lab 4341F, and it's a EFT image. I have multiple ones at the moment, but that's basically the path where the file is. Now I need to give it a name and a tag, and this is gonna be referenced here, right? So whatever you have here needs to match whatever name you import your image with. So in this case, I already have the compatible or the same software version. The nomenclature matches here, but if you have a different version and you want to import with a different name, it doesn't matter. There is no problem. You just need to ensure that whatever you do, use the same name here. So that looks good to me. And if you enter, it takes a few seconds. Looks like it's done. Now, if you do again Docker images, we do see the image here, right? And as you can see that it's called COS and 4341F. So at this point, I can just type clab or Containerlab deploy -t and point to the YAML file for my topology, which is called topology.yaml. And the deployment started. It usually takes few seconds, could take even minutes, depending on how big your topology is. Here is just a couple of devices, so shouldn't take long. As you can see now, it's done. So just few seconds, or maybe, yeah, like less than 20 seconds to deploy this topology. By the end, it gives you a summary of all the containers that are currently running. And we see we have only 2, which is expected. If I ever need to double check that, maybe you forgot about that and you want to confirm again what are the containers that are running, you can do clab inspect -t, the name of topology. You see, you get again up-to-date output here. Another cool and useful feature is that you can do clab graph, point to the topology diagram, and it's going to start automatically web server, and there will be a port forwarding here to your local machine. So you should be able to access this from your local machine now. So if I go back to my browser and I need to copy this, and you see here, I do have the topology. It's a very simple one, obviously. In this case, it's not very complex at all, but it's very useful to be able to do that. So you can just customize the way you like, so you can have a very clear idea of the topology you have running. We can stop that now. And next step is actually connect to some of those containers, right? So we created cEOS-1, cEOS-2, and there are multiple ways you can do it. The easiest one is just SSH to the hostname. You could SSH to the IP as well, or you can connect through Docker. You can connect to the console of the device itself. But for now, let's just connect to one of them. And you see that it uses admin by default, and the password will be also admin. You can change that in different ways afterwards, having different configuration, startup configs or templates, and we'll show that in the future. But for now, that's the basic way you can access the cEOS instance. As you can see here, we are running 4341 as expected, so all looks good. If you do show LLDP neighbors, you see that we do have a neighbor, cEOS2, and we can see that through the management as well, which is essentially a bridge. And then you can see that connected to our Ethernet one. We can, for example, one of the things that are cool is that you can just split terminal here, and then you can SSH to the other container, and that's it. So basically now you are in both containers at the same time. And if you want to configure stuff very easily, you can just set up like an IP address here. Oops. And then you can do the same on the other side. Just try to have some base configs here saved. So if you ping the other side, you see ICMP is working as expected. You can save the configuration, and you see that actually you see this structure that has been created with cEOS-Lab, the prefix cEOS-Lab dash the name of whatever the name you had here in the lab, in the topology YAML file in the name parameter. So this directory will be created, and you have subdirectories for each one of the instances, and all the files in Flash, for example, they will be stored here. So you can see here we do have everything, including the startup config. So if I click here on my File Explorer, now I can see the startup config of my nodes 2, cEOS2. So you see management IP was assigned automatically, management route as well, and we do have our interface Ethernet 1 configured as we just did here through the CLI. So it's very handy, because if you destroy this lab and you want to go back from where you stopped, it's fine. The information will be there unless you remove it. You can also remove it if you want to. If you want to start from scratch, it's up to you. So we're gonna see now how you can actually stop those containers. So as you can imagine, is again cLab, but this time destroy. And then you can point to the topology you want. There is also an option -A. You basically destroy all topologies without having to specify the name. Be very careful, because if you're running multiple topologies, maybe other users are using the same machine. This can be a problem. But if you're just running your own topology, it might be okay to do it if you don't remember the exact name, the exact file that you started. Another option is C. So if you use C or -- cleanup, it will essentially destroy the lab and also remove these files that have been created. So this is in case you want to start from scratch. So I'll do that actually. I will use all and cleanup options just to show you how it looks like. So you can see that the directory has been removed. And we also have, every time you run, you deploy a topology, backup of YAML file is created. So you can keep it if you want, you can remove it. It's up to you. Usually you don't really mind. And that's completely fine. Now let's do a speed run here to show you all these steps at once very quickly. So first step here, going to download page on Arista website, selecting the cEOS version we need. In your case here, we're gonna get most recent one, and then we'll make sure that we are getting the ARM version. We'll download to our computer. Then in the meantime, I'll open the OrbStack that has been already installed. The installation is quite simple. And then you go to new machine. You choose the distro that you are interested in my case, Debian. Apple Silicon is the chip. And then I'll deploy the virtual machine now. It takes few seconds. It's already running. I can just open via terminal here. Then I'll go to Containerlab website. I'll go to the installation. I'll grab here the installation script. Go to my terminal. Run the script. After running the script, I can see that Containerlab is now installed. Now I'm going to connect through VS Code, which is my preferred method. Make sure that you have remote SSH extension installed. Then click on the blue icon, connect to host. There is already an entry pointing to orb to my virtual machine. A new window will be open. VS Code will be installed on the virtual machine. Then the terminal is open already. We have our Debian here. Now I'm gonna open a folder in your local computer. You can also do that in the virtual machine itself if you prefer. That's completely fine. I'll use this demo directory. Again, now I'm here. Next step here, you can just create your own labs, or you can use Github. You have this example here, repository that I created. We can use that ourselves, so we can click on code, copy the address, then go back to our terminal, git clone, and that's it. Folder is created here with my YAML file. I can open the YAML file, and we see we have our base topology. Now next step, make sure that we import or the image that we just downloaded. So I go to my download folder, and then I need to give it a name. I'll use 435 COS 435.1F, which is the image that I downloaded, and this is the same we have already in the topology YAML. Just make sure that these are correctly set. Okay, now Docker image has been imported. We can see it here. We should be able now to just use clab deploy -t or topology YAML file and start a lab. Here we have our two instances created. You can now SSH to them, and we are there. So that's pretty much it. I already showed you how to configure things. It's basically the same as you would do on a regular device. The difference is that now we are running this as a container on top of Containerlab. We can then destroy our topology, and we can destroy all, or we can specify the topology we wanted to destroy. If you want to clean up all the temporary files, you can use -c as well. Hopefully that was helpful, and I will be creating more documentation and more videos showing you different things that you can do with Containerlab and cEOS. Thanks a lot for your time. See you next time. Cheers.